Hello, CAC Astronomy. My name is Yusuf Al-Hood, and today I'll be presenting to you about cosmic strings. So first off, what is a cosmic string? Well, first of all, it's theoretical, so we don't know if it's even exists, but it's fun to imagine. So these cosmic strings are reminiscent of the Big Bang, and they're one-dimensional strings of energy. So the idea of that, what one dimension is I want you to imagine just like a pole, right? Now, when we look at it, we know that it's 3D, like we know that there's width. But basically what one dimension is that there's no width at all. It's just one string. So it's like a con string, but extremely like way more thin than we can even imagine. And with cosmic strings, they're also known as superstrings or in the form of loops. Now, if you look at the pictures to the right, you can see that on the bottom, these superstrings are highlighted in yellow, so they can grow up like they can be in such big sizes, like stretching across like all over the galaxy, right? And they can also come in forms of loops. Now, I'll get how they're formed in loops, but loops are more smaller than the size of superstrings. So just to elaborate, what are cosmic strings? So, like I said, they were formed early in the universe, when the Big Bang happened. So, just to give you some sort of analogy to make this kind of concept easier to understand, let's look at the process of nucleation. So, this is basically when a material or like source of matter changes form. So, so something that we can connect this to is when water transitions to ice. So if you look at the picture, when water transfers to ice, the ice cube isn't, or yeah, ice cube or just ice in general, isn't particularly, not really clear, right? So there's these small defects in the ice, as we can see in the picture. That's basically what cosmic strings is to the universe. So how was it theorized? Well, it was theorized by Walter Bannerman Kibble, who's a theoretical scientist from the UK. So in the 70s, he theorized cosmic strings when he was working on the Higgs theory, which is a field theory in science where in the Big Bang, particles will shoot out that were given mass without altering its properties. And also, there's another unrelated theory that Thomas didn't work on called string theory, and string theory is relatively new. And in string theory, it basically says that the cosmic strings exist in one of 11 dimensions of space. And just to give you an idea what that basically means is that in every dimension there's a different force of nature. And the idea is that with string theory, with string theory, it's just one theory of all forces of nature that interact with each other to create a unified theory of which is also nicknamed the theory of everything. So what makes cosmic strings so hard to confirm their existence? Well, one of the things is cosmic inflation. Now, if you look at the graph in the inflation era, see how it formed right after the Big Bang. And in this time, all the cosmic strings would have been formed. Now, as time goes on and then the universe expands, the amount of cosmic strings doesn't change. So all the cosmic strings were formed in that small fraction of a second. And of course, as the universe expands, it gets bigger. But like I said, the amount of cosmic strings don't add up. In fact, they decrease. Because with cosmic strings, they naturally radiate gravity. And as time goes on, that gravity would shrink and then they end up disappearing. So, if you look at the graph again to just give you a scale, so you can see the formation of the Earth happened way after cosmic strings were formed. And time now, it's even more time. So as the universe accelerates and expands, the amount of time like cosmic strings could have just disappeared and we wouldn't know. And another thing is their instability. Like I mentioned, they naturally radiate gravity and they shrink, and then they end up disappearing. But if they form into a loop, which is when they accidentally touch another string, or it maybe like bends and touches itself, it ends up forming a loop. And when it forms a loop, it radiates gravity even faster, so it disappears much faster than it would by itself. So how do we find it? And what evidence can we gather to make sure it even exists? One thing, like I mentioned before, is their gravitational effects. And of course, if we think of space as like a flat plane of existence, and the sun bends space and time around it, which is why the Earth orbits around it, and then the moon orbits around the Earth, we would think that cosmic strings could have that same kind of effect, even though their gravitational effects would be very small. There would be hopefully some way we can detect their gravitational effects. And like I mentioned before, when it forms a loop, it would radiate gravity faster. Of course, that would be bad if we want to find its existence, because it would radiate faster and disappear faster. But as it radiates faster, it radiates gravity more, so its gravitational effects are heightened. So that's also an advantage to us, because it makes it much more easier to find its gravitational effects than it would if it's just a single string rather than a loop. So another way we can find their existence is through gravitational lensing. So what gravitational lensing is that through a telescope, if you find a picture like to the right, for example, you can see that the amount of light is bended. That's because there's so much matter there for the light around it to be bent. Now this way isn't. We can't necessarily disclude this way of finding cosmic strings, because like I said, the cosmic strings, they're just very small, and we don't know how much like gravity they emit. But this is a kind of pictures from like telescopes in space. So it's nice to think that this idea would still work for cosmic strings, even though they're small, because you need a large amount of matter and like gravitational effects for this kind of photograph image to take place. But we can't, like I said, we can't necessarily disclude this way of finding cosmic strings. So what other evidence can we gather for it to know that cosmic strings exist? Well, lastly, it's the cosmic microwave background. And what this image is to the left is the irradiation graph of from the radiation left over from the Big Bang. Now, like I mentioned, these strings are formed from the Big Bang. So the idea here is that we can find cosmic string evidence through this image from the radiation these cosmic string from the gravitational radiation these cosmic strings have. But that's about it. Thanks for listening. Keep an eye out for cosmic strings in the news for further development, because like I said, this is still a theoretical thing that we don't know it even exists yet. Thank you.